Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study the solving problems on motion under gravity. What is the motion under force of gravity or gravitational force or acceleration due to gravity? Here, it is a particular case of motion under a constant acceleration. It is denoted by letter G, and its value is taken as sometimes it is 9.83 meter per square second, sometimes it is 9.81 meter per square second, but we are going to consider this G value as 9.8 meter per square second. This gravitational force or acceleration due to gravity is considered when the body is moving or vertically upwards or falling vertically downwards. Under those considerations, we are going to consider in the place of acceleration, we'll consider this gravity. Suppose when the body is moving horizontally, then we use the equations of motions we considered in previous sessions, such as V equal to U plus AT, S equal to UT plus of AT square, V square equal to U square plus 2AS. That is for acceleration. Here, the V is final velocity, V for final velocity, U for initial velocity, where A for acceleration, positive acceleration, T for time, S is the distance traveled. Now, these are the equations are considered when the body is moving horizontally or on the road. If the body is moving vertically upwards or moving vertically downwards, in the place of acceleration A, G is to be considered, because when the body is in moving upwards, it is against to the earth, then the gravitational force coming into the picture. Under those situations, the equations become, in the place of A, acceleration, we are going to use gravity. Now, the equations of motion when the object is under gravitational force, then the displacement, we know that S equal to UT plus of AT square. Now, for this case, displacement S equal to UT plus of GT square. Next, the final velocity V equal to U plus AT in previous cases, but here under gravity it becomes U plus GT. And one more thing, final velocity squared, that is V square equal to U square plus 2GS, where S is the height, this vertical height. Now one more thing is that the time of flight T equal to 2U by G, where U is the initial velocity, V for final velocity, and T for time, and S for displacement or distance traveled. Now, this time of flight is going to be considered for the objects projected vertically upwards. Okay. Next, we are going to solve the problems by using those equations of motions considering acceleration due to gravity. Now, a stone is thrown upwards with a velocity of 4.9 meter per second from a bridge. If it falls down in water after 2 seconds, then find the height of the bridge. What is the height of the bridge? Based on the given data, the data is that velocity upwards, that is 4.9 meter per second, velocity that 4.9 meter per second, and the time was given 2 seconds. Then we have to find out the height h of the bridge. Now, if your stone is, that is the initial velocity that U equal to, it is thrown upwards, the velocity becomes negative, that is 4.9 meter per second, and the time is the 2 seconds. We know that the height of the bridge, okay, the distance traveled by the body, that is the meaning. So when the distance traveled by the body, that means we can understand the height of the bridge. So the height of the bridge, h equal to or s equal to ut plus of gt square, or h equal to ut plus of gt square. Substitute here these values in this equation, then that is minus 4.9 times u equal to minus or negative 4.9, where t is the 2 seconds, minus 4.9 times 2 plus of g equal to 9.8 times t equal to 2 square. If you substitute here the obtained value, the height of the bridge, that is 9.8 meters. This is the height of the bridge. Another name is called the distance traveled by the body from the bridge, okay, thrown upwards with a velocity if it falls down after 2 seconds. That height we can know it, okay. That the height of the bridge is we calculated here, it is 9.8 meters. Next problem, here it is, we are going to solve the next. So a packet is dropped from a balloon which is going upwards with the velocity 12 meters per second. Calculate the velocity of the packet after 2 seconds. After 2 seconds, what is the velocity of the packet? So here, same, the concept is that velocity of the balloon when the packet is dropped, that initial velocity, that u equal to negative, that is the minus 12, negative 12 meters per second. This minus sign is due to upward motion and the time 2 seconds. So when the packet is dropped, so its initial velocity u equal to negative 12 meter per second. Now velocity of the packet after, we want velocity of the packet after 2 seconds. Okay, we want velocity of the packet after 2 seconds, that means final velocity. The final velocity equation is that final velocity equation of motion by considering the gravity, that v equal to u plus gt. So substitute over here those values, initial velocity u and the time t and gravitational acceleration g 9.8. So negative minus 12 plus g 9.8 times 2, then minus 12 plus 19.6, then it is 7.6 meter per second. So the initial velocity is 12 meter per second, then final velocity becomes 7.6 meter per second. So the final velocity is reduced. Why the final velocity reduced? Here you may say positive or negative. It is the it is the direction. It indicates the direction. But the final velocity positive 7.6 means coming downwards. Okay. Why it is becoming reduced to? Because here the gravitational force is acting. This gravitational force making it, that's why it is affecting the gravitational force. That's why it became what? That the final velocity is reduced, that is 7.6 meter per second. Now coming to the next, the problem comes under the category of the time of flight and the range of projectile. So the time of flight and range of projectile are also comes under the category of a motion under gravity. Now here the problem is that a ball is kicked off of the ground with an initial velocity of 20 meter per second, with an initial velocity of 20 meter per second at an angle of 45 degrees to the horizontal, an angle of 45 degrees to the horizontal. Calculate the time of flight on the horizontal range of the ball. So we are going to calculate this time of flight and horizontal range of the ball from the concepts, from the basic concepts of the equations of trajectory. Now we are going to solve that. First we need to find out the time of flight. That is the first objective. So let us begin with the first objective. Further, the vertical component of the initial velocity, that is uy equal to u times sine theta, that is u times sine 45. What is the u for here? The u for u here, the value of the u is 20 meter per second, and it times sine 45, that is 14.14 meter per second. So the time of flight can be found using the equation. There are another equation that is equal to u by g, and also here uy equal to g times t. What is the g times? Where is the g is 9.8 meter per square second, and what is that uy? That time t equal to uy by g. Time from this equation t equal to uy by g.
What is the uy here? That is 14.14 meter per second by z 9.8. If you make a substitute here, 14.14 meter per second by 9.8 meter per second square, then it will be cancelled meter per second, the obtained value, the time of flight, that is 1.44 seconds. That is the first objective. The second objective we have to find out is the horizontal range. For horizontal range, we need a horizontal component of initial velocity, that is ux, that ux equal to u times cos 45. That u times cos 45, what is the u value here? 20 meter per second times cos 45, that is 14.14 meter per second. So ux and uy both are same. Why? Because the angle of inclination is 45 degrees. So sin 45 equal to cos 45, the value remains same, 1 by root 2. That's why the ux and uy both are same, that is 14.14 meter per second. Now the horizontal range that can be calculated, that is using the relation equation, is that horizontal range that equal to horizontal component of velocity times t. Okay, that is meter per second. Yes, this is nothing but s equal to ut, that horizontal range, that equal to ux times t, that is 14.14 times 1.44, that is 20.38 meters. That is the horizontal range. The horizontal range is initial distance, the point of initial projectile to the landing projectile. That distance, horizontal range, is known as the horizontal. That distance is known as the horizontal range. Suppose here, the point from here, projectile angle is projectile and coming down. From point A, it was projected from here and it is landed at point B. The distance from A to B is known as the horizontal range. The angle of inclination of projectile, here it is 45 degrees. Okay. Now what about the horizontal? The horizontal component ux equal to u times cos theta, because the 45, so it becomes cos 45. What about uy? That uy equal to u times sin theta, that is u sin 45. Okay, that is ux u cos 45, uy u sin 45. Okay, then the distance between point A to point B, that is known as the range. That range is calculated as 20.38 meters. So the answers for this problem, the time of flight is 1.44 seconds and the horizontal range is 20.38 meters. What is that meaning here? The time of flight means the time at which the projectile has taken time to reach the point B. From point A to point B, the time taken by the projectile is 1.44 seconds. When the velocity of the projectile, initial velocity of the projectile is 20 meter per second and the angle of inclination, the angle of projectile is 45 degree. 45 degree and 20 meter per second, then it becomes what? The time, the traveling time, the total time taken to reach from point A to point B is 1.44 seconds. On the horizontal distance, okay, that is horizontal distance is 20.38 meters. Okay, that's what here we calculated time of flight and horizontal range. Okay, next we see the second consideration of the problem. Here we are going to calculate in this problem maximum height and time to reach it. There are two things: finding the maximum height of the projectile and the time to reach it. What is the time to take it to reach the objective? Now here we considered here a stone. A stone is thrown vertically upwards with an initial velocity of 25 meter per second. Vertically upwards with an initial velocity of 25 meter per second. Yes, that's it. Determine the maximum height reached by the stone and the time taken to reach it. What is the time? Now let us begin. What is the maximum height when it is thrown with vertical upwards 25 meter per second? We are thrown the velocity of, that is 25 meter per second, thrown vertically upwards. Only one parameter was given, but you have to find out the height. H equal to ut plus of gt square. We'll see we know that we have final velocity equal to u plus gt,
and the final velocity square equal to u square plus 2g to gs, and one more thing, s equal to ut plus of gt square. We have to find out, yes, gt square, the time ut plus of gt square, v square plus u square up to d. By using these three equations of motion, of the force under the motion under gravitational force, we have to calculate the maximum height reached and the time taken also. So here, to find the maximum, let us begin the solution. To find the maximum height, we are going to use the equation for vertical displacement. The initial velocity was given here. This 25 meter per second is considered as initial velocity, and the final velocity at which the highest point, the final velocity is 0, with which the 25 meter per second the objective is throwing. But what is the final velocity? It reaches the maximum height, the final velocity becomes 0. So initial velocity is 25 meter per second, final velocity is 0. And here, and since the stone is momentarily stops at that point. Momentarily stops means it's going to be stopped and comes back from that point. So which equation among these three, which equation is going to use? We are going to use based on this explanation. Yes, you might have got it already idea which equation. Okay, we'll see. Now here the equation we are going to use v square equal to u square plus 2gs. Here that is where a is the acceleration due to gravity, that is 9.8 meters per square second, and s is the maximum height. Here v for final velocity, u for initial velocity. So the value of the final velocity is 0 and the value of the initial velocity is 25 meters per second, and substitute here, that is 0 square, this is a meter per second square, that is 0 final velocity, and u is the 25 plus 2 times g 9.8 negative 9.8 times s. The s is the maximum height reached by the stone when it is thrown upwards with a velocity of 25 meters per second. So the maximum height reached by the stone objective is 1.28 meters with this velocity. Now the negative sign of here indicates that the displacement is in the opposite direction of the initial velocity upwards. Okay, now next one. Find the second objective, the time taken. To find the time taken to reach the maximum height, we can use the equation. The time taken to reach the final velocity equal to u plus gt. Now, whatever g here, 9.8 meters per square second, u is 9.8 meters per second, u is 25 meters per second, v is the final velocity, it becomes 0. After plugging these values into the equation of the final velocity, that is v equal to u plus gt, v equal to u plus gt, v for g, v is 0, u for u is 25, and g is minus 9.8 times t. And the time we are going to obtain, that is 2.55 seconds. Okay. So therefore the maximum height reached by the stone is approximately how much? 1.28 meters, and the time taken to reach the maximum height is how much? 2.55 seconds. To reach that height, how much height? 1.28 meters. How much time? 2.55 seconds. Time was taken. Alright. These are the two objectives. The next problem is, your body is dropped from the top of the building. If it takes 2.8 seconds in falling on the ground, your body is dropped from the top of a tall building. Your body is dropped. It takes 2.8 seconds in falling on the ground. Find the height of the building. We already covered this model. Before that, bridge consideration. Find the height of the bridge. A stone is thrown or a body is thrown. Now here, the initial velocity equal to 0 because it is dropped, and the time taken is 2.8 seconds. Yes. Now the equation height of the building, that is equation, if you by plugging these values into the equation, that is s equal to ut plus of gt square, s equal to u times u equal to 0, t is the 2.8 seconds, and g equal to 9.8, and time t is 2.8 of g 9.8 times 2.8 whole square, that is 38.4 meters. That is the height of the building. Okay. The next one, a stone is dropped from the top of a building. A stone is dropped from the top of the building, which is 65 meters height. The height of the building is 65 meters. Oh, is highly. Okay. theoretically mentioned, idealistic. With what velocity will it hit the ground? Okay, it is 6.5 meters, it is reasonable, it is 65 meters high. Okay, with what velocity will it hit the ground? Now initial velocity equal to 0 because it is dropped and the height of the building is how much? 65 meters. We need what is the final velocity? Initial velocity, final velocity, and the height. These three parameters, these three things are there in one of the equation of motion, that is v square equal to u square plus 2gs, where s is the height of the building. By substituting those values into this the equation, v is the final velocity that is the required. Use the initial velocity 0, g is 9.8, s h is the height of the building 65. After substitution here, that is v square equal to 1274, where v equal to 35.7 meter per second. 35.7 meter per second, that is the final velocity. So the velocity with which it hit the ground, which one? The stone. The stone which is hitting the ground with a velocity of 35.7 meter per second. Okay. If we convert into kmph, then you can understand with what kilometer per hour it is hitting. How to make it? Okay, let us make it 1 kilometer per hour. 1 kmph, that is 1 into 1 kilometer is 1000 meters. Hour is 3600 seconds. So 10 by, then what happens? 5 by 18. So 1 kmph is equal to 5 by 18 meter per second. So 1 meter per second equal to how much? 18 by 5 kmph. 18 by 5. So 1 meter per second, if you 1 kilometer per hour equal to 5 by 18 meter per second. If you want to convert this meter per second, so we into kilometer per hour, that is 18 by 5 kilometer per hour multiplied by 35.7 multiplied by 18 by 5, then we will get it as so and so kilometer per hour with which the stone is hitting the ground. The next problem here, a body is thrown vertical upwards with a velocity of 28 meter per second. Find the distance it will cover in 2 seconds. So initial velocity u equal to minus negative 28 meter per second because minus n due to the upward motion and the time t equal to 2 seconds. We know the distance covered by the body s equal to ut plus of gt square. By plugging these values, the initial velocity and the time into the equation s equal to ut plus of gt square, that is u4, that is negative 28 times t 2 seconds plus of g is 9.8, where the t is the 2 square. So after substituting here, negative 56.19.6, that is 36.4 meters. Now the distance covered by the body, here it is the 36.4. What is the negative sign indicates? It indicates the body will cover the distance in upward direction. It is going upward direction. That's why here it is negative sign. The indication of the negative sign is the body is moving the distance in upward direction. That's why here it is negative 36.4 meters. Yes, the 28 meter per second, if you throw in 2 seconds, it travels 36.4 meters. Wow. Yes. The next one is a bullet is fired vertical upwards with a velocity of 80 meter per second. A bullet is fired vertical upwards with a velocity of 80 meter per second. To what height will the bullet rise above the point of projection? Now here initial velocity u equal to, that is minus 80 meter per second, minus sign due to the upward motion again, and the final velocity v equal to 0 because at that point when final velocity is 0, at that point there it reaches the maximum height. After reaching the maximum height, the final velocity momentarily becomes 0 and it comes back. Now where is the s is the height to which the bullet will rise above the point of projection. So we know 3 equations of motion, that is final velocity v equal to u plus gt, and another one s equal to ut plus of gt square, v square equal to u square plus 2gs. These are the 3 equations of motion. We have to use based on the data. What is the equation here? Initial, final, we need s. What is the equation? V square equal to U square plus 2GS. That is the equation of motion. That V square equal to U square plus 2GS, where V equal to 0 and U equal to minus 80, that is minus 80 square plus 2 times G, 9.8 times S, where S is the height. Now the height with which the bullet rises the point of projection, that here we substitute over here, the final velocity is 0, initial velocity is negative 80, 2 times G, 9.8 and S. The S value is obtained as minus negative 326.5. So again, what is the distance? The distance is what? Upward direction. That's why it's a negative sign. That is minus negative 326.5 meters. Because the velocity is high, that's why the initial velocity is 80 meters per second. So here the distance traveled by the body in upward direction is based on the value of initial velocity. If the initial velocity is high, okay, what will happen if the initial velocity is high? The distance height will be high because the final velocity is 0. So it is proportional. The distance is depends upon the initial velocity. Okay, it depends upon the initial velocity of the body. The next problem is that a body is released from a great height, falls freely towards earth. Okay, another body is released from the same height exactly 1 second later. First one is a t, means another second body is a t minus 1 seconds. Find the separation between both the bodies after 2 seconds of the release of the second body. Okay, after 2 seconds of the release of the second body. Now, the initial velocity of both the bodies, the initial velocity is 0. Now, the time taken of the first body, that is the first time taken by the first body is 3 seconds. Okay. Next, the time taken by the second body is initial minus after the 1 second, that means t minus 1, that is 3 minus 1, that is the 2 seconds. Now, distance covered by the first body in 3 seconds, that is h1 equal to ut1 plus of gt1 square. What is the h1 equal to u1 equal to 0 and the t1 equal to 3 of times g is 9.8 times t1 square, that is 44.1 meters. That is the h1. Next one is the distance covered by the second body in 2 seconds. The distance covered by the second body in 2 seconds. First body in 3 seconds, second body is after releasing the first body, after releasing 1 second of the first body, the second body was released. That's why that is a 3 minus 1, 2 seconds. Here the time t2 equal to 2 seconds. Okay. Then h2 equal to u t2 plus of g2, is gt2 square. Times here u equal to 0, t2 equal to 2 of times g is 9.8, t2 is the 2. Then it is the 9.6 meters. The separation, the distance, separation between the two bodies, that is means body 1 distance and body 2 distance, a difference between two bodies, a difference is that at 24.5 meters, that is 44.1 minus 19.6 meters, that is h2 minus h1, that is 24.5 meters. That is separation between the bodies. Separation between the bodies, that is 24.5 meters. Okay. This is the problem here. Now, what are the things we covered in this session? Let us begin. There are various problems we covered. Some other problems we covered were the distance, separation between the bodies, and the time related, and also horizontal range, time of flight, and maximum height reached by the body. All these problems, the common principle is only one thing. What is that one thing? The bodies are under the gravitational force. So the gravitational force consideration comes into the picture when the bodies are thrown vertically upwards. When the bodies were moving either upwards or downwards, it affects because of, in the place of acceleration, the acceleration due to gravity to be considered, that the factor g is to be considered. Okay, now in this session we covered different things, and also what are the references here. The references were followed: the gravity motion PPT, that is from openai.com, RS Courtney, Irving Shams, RS, that is Hibbeler, the Beer and Johnston vector mechanics for engineers. These are the references were followed. So the session was considered purely motion under gravity. Further explained what are the things. The things were explained here mainly. That is, we consider the equations were considered here. That v final velocity v equal to u plus gt. The next final velocity square v square equal to u square plus 2gs, and the distance s equal to ut plus of gt square. By using these three equations of motion under gravity, we solve all the problems. Okay, with this we can say thank you.
Like, share and subscribe. Hit the bell icon for more updates.